Hey everyone, we're going to be starting the new chapter. It's chapter 10 and it's called Counting Methods. Applying counting methods helps us find the number of outcomes when your event size is very big. So to illustrate that as an example, in the 6th century BCE, that's 2,600 years ago, that's amazing, ancient Indian physician is like a doctor, Sushruta, asserted that from the 6 taste senses in the mouth, there are 63 combinations of tastes, taken one at a time and two at a time, and so on. So what that means is if you consider the different tastes, like sweet and sour and so on, one combination would just be something that's sweet, like a lolly. Another combination would be something that's sour, like a lemon. There could be also combinations of those as well. Sweet and sour, something you might have tasted the last time you went to a Chinese restaurant. But hopefully you can see that very quickly we've got many combinations of tastes, and it's going to be very tedious to list out all the different combinations of it. But this physician was able to tell that there are 63 different combinations by using a counting method. So the rule became 2 to the power of 6 minus 1 possibilities. You can check that it does equal to 63. We're going to be learning this counting method to help us calculate the number of combinations in a certain event. It's going to be very quick and it's going to be very powerful because most problems in probability do involve very large outcomes. We're beginning our first exercise and it's called the addition and multiplication principles. Our learning intentions are to introduce addition and multiplication principles of counting, to apply the addition and multiplication principles to find the number of outcomes for a large sample space. And our aim is to apply the addition and multiplication principles to find the number of outcomes. This is going to be related to probability when we're finding the number of outcomes in a certain event, so we can use it in a probability formula. To introduce these principles, we're going to formalize some simple rules from some simple examples. These examples will have numbers that are quite small, numbers where you wouldn't think that a rule is necessary to find them. But the idea is that by applying these principles to simple numbers, you can see how they apply to large numbers as well. Here's the addition rule. We're going to be taking these examples from your exercise book, and here's question 1 from 10A. Find how many choices of books are possible if one book is to be selected from your bookshelf of 8 novels and 3 dictionaries. So pretend going on a trip and you're only allowed to bring 1 book. So how many different possible ways can you choose 1 book? Well, that's just from the total number of different books in total, right? So from a total of 8 novels and 3 dictionaries, there are 11 possible ways. In the second question, we're going to use some slightly higher numbers. How many choices of books are possible if one book is to be selected from 22 romances, 14 mysteries, and 1 autobiography? Once again, we consider the number of books in total. Because we're only selecting 1, we've got 22 and 14 and 1, which is 37 possible books to choose from. These are examples of the addition rule. So let's formalize our explanation. When choosing between alternatives, add up the number of choices available for each outcome. Often, the key word involved here is or. I realize that there's actually no or in these questions, but I could insert it into question 8 novels or 3 dictionaries, or 22 romances, 14 mysteries, or 1 autobiography. In addition, notice that alternative, it's actually a synonym in this case to mutually exclusive. That means the different sets you're picking from have nothing in common from each other, apart from the fact that they're all books. So for example, if you're picking a novel, that means you can't have picked a dictionary. Since we're involved with mutually exclusive sets, when you're going to pick one from those different sets, you can just consider the entire set by adding up, in this case, the different novels and the different dictionaries. Now we're going to be looking at the multiplication rule using a simple example. So this is example 2. I'll pause here and just mention that there are digital notes that are available for you from Google Classroom. And what I recommend is just following these examples in your digital notes and copy down our worked examples as we go. Find how many different meals are possible if 3 courses, which form 1 entree, then 1 main course, and then 1 dessert, are to be selected from a menu that lists 3 entrees, 4 main courses, and 5 desserts. Okay, well, the title's multiplication rule, so it's got to be in there somewhere. But let's try and draw a tree diagram first to see how the multiplication rule fits in. We start off by selecting one of 3 entrees. That's our first stage. Because those entrees are different, I'm going to be labeling it with different numbers. Okay? 3 different choices right from the outset. After you choose your entree, there are 4 possible main courses to choose. M1, M2, M3, and M4. Now, if you do manage to choose your main course, then you've got one of 5 possible desserts to choose from. Now, let's write that down. Hopefully you can see that very quickly this tree diagram is getting very big. So let's quickly try and find a way of fitting the multiplication rule. If we put this together, how many different ways can we choose a 3-course meal? Notice that each of these entrees have 4 different main courses, and each of these main courses have 5 different desserts. So the total number, in total, we've got 3 different entrees to choose from, and each one of your entrees have 4 different main courses. 3 times 4. And each one of your main courses has 5 different desserts. 3 times 4 times 5. I'll just label these numbers, E, M, and D, to keep track of where we got them from. Now if we evaluate this, 3 times 4 is 12, 12 times 5 is 60. There are 60 possible 3-course meals that you could choose from. And the way we got the number 60 was to multiply the number of options in each successive step. Now let's summarize this. This is an example of the multiplication rule. When sequential choices are involved, the total number of possibilities is formed by multiplying the number of options at each successive stage. Often, the key word involved here is and. So this is the and I'm looking for. I'm going to have one of each, and they're happening in succession. Okay, I'm going to sneak in one more example that's not in your digital notes. And I think this example is important because it demonstrates that in some questions, you're actually using the multiplication and addition principles together. Let's use this example. So let's say you're traveling to Sydney. One of the ways you can get to Sydney is get mum to drive you to airport and then take one of 4 possible flights from Melbourne to Sydney. You can do that, or you could also take one of the 2 buses that go to Melbourne Central train station, and then from the train station, take one of the 3 trains that goes to Sydney. So how many possible journeys do we have? Let's split up this question into parts. First, we have the 4 possible flights, which means right away we've got 4 different ways. 4 from the 4 possible flights. But in addition to that, we also have the possible trips by bus and train. Now you take a bus and then take a train. There's that hint to use the multiplication rule, because I know each of these buses has 3 different trains to choose from. So the number of ways based on buses and trains would be 2 buses by 3 trains. So here, notice that we've used the notice that we've used the multiplication rule. 2 buses, and each of the 2 buses has 3 train trips. And then we add them together with 4. That's the addition rule at play, because we know that if we're not going to take a bus and train, we must be taking a flight. They're mutually exclusive events, so we add the different combinations together. And what is this equal to? 4 plus 6, and that's equal to 10. Now I'll wrap this up by saying, look how quickly we were able to get our total number of journeys. That's the power of counting methods. You're able to get the total number right in one step. Let's wrap up our first exercise. We've introduced the addition and multiplication principles of counting. And we applied the addition and multiplication principles to find the number of outcomes for a large sample space. Well, 10 journeys isn't that much, but as you work through the exercises, you'll be applying it to bigger and bigger numbers. Success criteria can apply the addition and multiplication principles to find the number of outcomes. To check whether you've achieved the success criteria, I recommend that you now go down below this video and attempt some of the quiz questions from Style. That'll give you some feedback right away about whether you're ready to continue. Please remember to bring some of the questions that you've had from this video to class so we can explore them during question time. That's it.